All right, here you go. Find the angle of the ramp to the first hundredth of a degree. Right triangle, I can use sine, cosine, tangent, or I could use law of sines. All right, I'm going to use SOHCAHTOA here. All right, everyone see the angle I need? What's the 1 acting as? What type of side would the 1 be if that's the angle? That's my opposite side, and the 12 would be my adjacent side. So according to SOHCAHTOA, I'm going to use tangent. Tangent of x equals opposite 1 over adjacent 12. When you find an angle, we do not cross multiply. We do not cross multiply. We go back into our calculator and do the inverse, whatever function I use. In this case, tangent, I plug in 1 over 12. Please make sure your calculator's in degree mode. Tomorrow, we're going to practice resetting our memory because you'll have to do that on the exam before you start. So tomorrow, Friday, and Monday, we'll just quickly review resetting. And then the one thing you do have to remember when you reset your memory is to go back to your mode and put in degree mode. It should never be taken out of degree mode. More here. Let's go. Next up, Kate, go. Sorry. 34, everybody. Okay, Kira and her poster. This one was a tougher one, no doubt. That's why I was in the part 3 section. Okay, first thing is just let's make sure we understand what's being asked here. The question is determine and state the total area of the poster and the frame. So bottom line, everything, this full figure I have up here, the area of everything. So what I need to find is, all right, if you want to find the area of the whole thing here, I need to know what this side times that side is going to be. All right, let's help me find those sides. Well, it is a square inside. There's a diagonal of 58. That means it forms a right angle. Oh boy, anybody know those angles? It's a square. These sides are equal. What are those angles? Yep. Now, could you do Pythag? You could do Pythag here. If you want me to show that at the end, I'll certainly show it. All right, so 45, 45, 90. Unfortunately for us, though, what side am I given? The side across from the 90. Yeah, that's not the best position to be in because how am I going to have to go backwards? I'm going to have to, oh boy, go backwards. I multiply to get here. I'm going to take 58 and divide it by radical 2. All right, how do I get that radical out of there? Top and bottom by radical 2, so I end up with 58 radical 2 over 2. And the 58 and the 2 do divide out. Oh boy, what was that, 39? No, come on, you're better than that. 29 radical 2. And since we're at this point in the year, if you want a little shortcut so you don't have to do all this, anytime you go backwards on a 45, 45, 90, and put a radical 2 with it. That's it. Just cut that number in half and put a radical 2 with it. That's what it's going to end up being. All right, so we're still not even close to being out of the woods. 29 radical 2, and this one right here is going to be 29 radical. That's embarrassing. This is Regents time. There we go. 29 radical 2 on going this way. But I need to find, hey, I need to find that full side. I need to find that full side. What else do they give me? The width is 4. So you are going 4 this way and 4 this way. All right, so this whole side right here is going to be, do it with me there, 29 radical 2 plus, what am I adding on to it? 8. Times, now do the same thing with this side here, or this side, they're both the same. 29 radical 2 plus 4 here and 4 here. So the other side is also going to be 29 radical 2 plus 8. Everyone's got calculators. We can round to the nearest tenth when we're done. All right, that sucker was tricky. All good there? With Kira and her poster board? Will? We absolutely can. Oh, yeah, I love this thing right here. Why wouldn't I, right? It was challenging, yet not impossible. Let me put it, that's why I liked it. Challenged you, but not impossible. Okay, thanks for asking it, Will. I'm not going to go through and write down step by step here. We'll talk it through, but that's about it. I did mention in this class that the part 4 is going to be one question. It's going to be a proof. I know there's 2 part 2s in your packet right now, but starting in January of this year, they eliminated one of them and kept the proof. Okay. Next, there used to be 2 questions in part 4. There used to be a proof and then like density, very tough question. Now it's just the proof. Yep. Okay. Next thing I'm going to say, focus in here. Next thing, because it happened 2 years ago. Hey, I realize there's a lot of givens up here. If you pull this, you're going to get a point off. And that's not a me call. All right. That's what they told us to do 2 years. That if you just plop that in there without writing down the actual givens, it's going to be a point off. Okay. So you do have to write the full givens in. Take the time. You have to be there for 2 hours anyway. All right. Can't leave until 2 hours is up. Good there? Are we okay if I do that now just for time's sake, even though I'm definitely not practicing when I'm preaching? Okay, first thing, this is an isosceles trapezoid. Anybody know why they tell us the bases are DC and AB? What do you know about the bases of a trapezoid or an isosceles trapezoid? They're parallel, so that's how I know DC is going to be parallel to AB, meaning the other 2 sides have to be what? It's an isosceles trapezoid. The non-parallel sides have to be congruent. Yes, congruent. So that tells me DA is congruent to CB. Now, that was not given to me. That had to go in your proof. That DA is congruent to CB. Isosceles trapezoid implies non-parallel sides congruent. That was not a given. And I'm sure a lot of people forgot to put that in this year. That year they took it. Okay, let me mark everything else and then I'll start talking to you guys here. Segments, yep. CDE, okay, these 2 right here are congruent. And we got perpendicular going right here. Got it. Okay, again, for time's sake, I'm not going to write everything down, but we can discuss what should be in your proof. I saw the way the guy did it on JMap, and I did it a different way. Okay, I did it a totally different way. The first thing we had to do was prove the triangle's congruent right here. Those 2 angles are congruent. What's across from them? In a triangle, congruent sides are across from congruent angles. So everyone all right? Why DE would be congruent to CE. In a triangle, congruent sides are across from congruent angles. And then I already knew those 2 triangles were congruent. I didn't need anything else. Anybody know why? What method right now those 2 triangles congruent? It's HL, everyone. Everyone see HL? It's not side angle side. It's not side angle. Don't be that kid, please. It's a right triangle. Here are the hypotenusae that are congruent, and here are the legs that are congruent. These 2 triangles are congruent by HL. Yep. Oh, I got to say a lot before I say HL. I got to say, here you go. Here's what I need to say. You got to say DE congruent to CE. I got to say these are right angles. I have to say these are right triangles, and then I can roll with HL. Okay, everyone good with that? Got to tell me they're right angles. You don't need to tell me they're congruent if you're going to use HL, but you do need to tell me they're right angles, they're right triangles, and then you can roll with HL. Amy, go ahead. Because this is a triangle right here where I have two congruent angles. That was given, right? So in the same triangle, congruent sides are across from congruent angles. Others, I know the guy did it like angle side, angle side, something like that. That's fine. I did a little differently, HL. Everyone good on proving the triangle's congruent? Will, you good? Because now we got this next part, which is prove this triangle in the middle is isosceles. What did you just prove about these two triangles? They're congruent, so all their corresponding parts are congruent. In particular, what two corresponding parts am I referring to? AE is congruent to EB because of CPCTC. Why is that triangle isosceles? Two congruent sides implies an isosceles triangle. I like that one a lot. I did. I like that one a lot. While we're on the topic here, why not just go through everything? Isosceles trapezoid. Other properties. Because I did not even sniff any of the other properties. There's two other huge properties that you should be aware of isosceles trapezoid. Non-parallel sides congruent. We got that. There's two other huge properties. Base angles are congruent. What do I mean by base angles? Not just the bottom angles, but also the top pair as well are congruent. And there's one other huge property, but I haven't drawn them in. Diagonals are congruent. Yes, diagonals are congruent. And I'm sure that's in your facts to know. Is it in there? Facts to know packet. Yep. All the what? What do you mean shapes? Like quadrilaterals? All there. All there. Emily. 13, everyone. Turn to 13. Okay, what are we looking at for the multiple choice here? Rotate it around, yep. A rectangle whose length and width, yep, is shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150. Which line could this rectangle be rotated around? Ooh. The long side, the short side, the vertical line of symmetry, the horizontal line of symmetry. Well, first of all, if I start rotating this around, anybody know what that object would be? Oh, a cylinder. Okay, yep. Okay, so a cylinder, and we're talking about volume. Where can I find that formula? Darn right, your reference table. Volume of a cylinder, anybody? Pi r squared height. Now, I need it to come out to be 150 pi, Emily, right? Okay, so let me take both of these right now. If I rotate it around the long the long side here. Okay, if I rotate it around the long side here, what would be your height? Because now here you go. Mark right there. I have no idea why I just took this back. Banging it. Ah! Eraser got in my way. All right. I'm just going to take the high road and not say anything. All right, I'm going to be classy about this. Okay, ready? If I go around the long side, ready? So I'm going to fold it along the 10 side. There's my cylinder. What's my height here? 10, right? Now I got to do a little work because That 6 represented the what here? That's my, oh, no. 6 is this distance all the way around. Circumference, right? So I got to go off to the side and say 6 equals pi d. Divide by pi, right? And then whatever that radius happens to be, plug it in, okay? Versus now, what that's long side. What would happen if I rotated it around the short side now? Okay, what would be, okay, short side. What would be my height now? Okay, see how this changes now? And then now it would be 10 equals pi d. Okay, then I would plug that in for the radius and see if I got 150 out of that one. Okay, good so far? Everyone else all right? Good? Other questions? Nothing else there? Yep, Hugh? Oh, you think it's 19, okay. SOHCAHTOA again? Except now you're finding a side instead of an angle measure, so I shouldn't be using my inverse button. So what do I got? C, B, A, C. Angle B is the 90, AC 6.2. Angle A 32. What's the length of BC? All right, what's the 6.2 acting as? Hypotenuse. And what about the X? Opposite. What do I use with O and H? Sine of 32 equals opposite over hypotenuse, and I cross multiply. Okay? Probably need that for later. Anything else? Yes, Amy? Okay, this would be one of the ones I'm going to do today, so I might as well start with that right now. 17, this is your partition. That's the word I was looking for, partition questions. You're going to break A and B up into a ratio of 3 to 5, meaning how many congruent parts? 8 congruent parts. All right, so let's start with the X coordinate. Anybody want to let me in on what X coordinate I start and go to? -8 all the way to 16. That is a long distance, everybody, on the x-axis. How long is that on the x-axis do you travel from -8 to 24 units? And you're breaking it up into what? 8, right? And then you're going to end up multiplying by what after you break it up into 8? Okay. I think I showed this to you guys. Instead of doing more steps, saying divide it by 8, multiply it by 3, you can just multiply by 3/8. Divide by 8, multiply it by 3, and divide by 8. I will talk at the end, yes, always, why you never use the last number. Okay, I'll talk what that purpose is. What's 3/8 of 24? 9? That tells you how many units you're going from the beginning. Where did I start from the beginning? -8, and I'm going 9 units. So where do you end up on the x-axis? At 1. I guess we can stop, but we don't go halfway here. This might be in a part 2, so let's keep going. Y coordinate, where do you start? -2, and you go to 6. So now you go from -2 up to 6. How many units? 8 units. Still multiply by 3/8. And that'll be 3. Where'd you start again? -2 plus 3. Where do you end up on the y-axis? 1. Now, Cam mentioned, what about going from the 5? No. You know when you would use the 5? Going from B to A. Okay, going backwards from B to A. We will never have the need to do that. So you stick with that first number. 3. Okay, you stick with the first number. Emily?
For the number 19 that we just did, could you use law of sines too?
Yes, you could. Yep, law signs is always an option for any type of triangle, but remember, SOHCAHTOA, only a right triangle. That's why I showed you guys law signs. I like it a lot. Any triangle it can be used in. Other questions here? Anything else? Okay, we ready here? Might as well stay right here. 17, go to 20, right? Pretty close to it, go to 20. Some of you may remember this question. This is where I got it from. Except I don't think I had the multiple choices in there. Yep, write them in order. Yep, and he had to show mathematically instead of just I was thinking about a map. Okay. I want to go over this because it uses a formula that's not on your formula sheet, and that's population density. Anybody remember the formula for population density? Even though it's right there in the chart. Population over area, yep. Population over area. That's one you're responsible for in a couple Tuesdays. So as you go through each of these here, so if we start with Florida, the population density in Florida, 350.6. And I know the population's a little over close to 19 million, but 18,801,310 all over the area, which is what we're trying to find. And I want to go over this a second time because I remember on your quiz, some of you forgot how to solve this. All right, because you just can't multiply these two. You got to cross multiply, so 350.6x equals that 18 million. And then what should I be doing on both sides? Divide by 350.6. And then you'll come up with the correct land area for Florida. You do the same thing for Illinois, New York, and Pennsylvania. And the other thing just to pay attention to is the directions. You're going largest to smallest. Largest to smallest. So once you find out, hey, all I have to do is take population divided by the density, it goes pretty quick. You don't have to set up a proportion every time. What do you have next period? The one with the highest land area. That would be my last guess, but it is correct. A lot of people, I'm sure, would go with the FL, huh? Florida for you kids. Got your formula sheet, good. Okay, so it ended up being Illinois, which had the largest area, followed by Florida, New York, and Pennsylvania. All right. Okay, let's keep this moving because we got another proof to do at the end. Yeah, I know you're excited. 24, last multiple choice. Here we go, last multiple choice. What's the equation of the perpendicular bisector of that line? Okay, sure, yep. Okay, all right. All right, here, perpendicular bisector. Let's start talking about the perpendicular part. It's got to be perpendicular to that line segment. What am I going to start looking at? Slopes. What should I know about slopes and perpendicular lines? That's parallel. Opposite reciprocals, negative reciprocals, whatever you call it. Can you please find me the slope of the segment? Either change in y over change in x or rise over run. It's up to you. Up and over how many? What's the slope of the line segment? Change in y over change in x, or again, rise over run since it's already graphed for you. And here's where I'm going to start asking people right now. Here we go. Get it going for us right here. 15 when you're ready. What's the slope of that line? -2. Nice job. It's going downhill, so it's negative. Slope of the perpendicular bisector now. Slope of my perpendicular bisector. What do you got for me? 9?
That would be 2.
You sure? Reciprocal. I got to flip it.
Oh, 1/2.
1 positive 1/2. Everyone good? Positive 1/2. Now, let's take care of the bisector part. This perpendicular bisector is going to go through what of the segment? Midpoint of the segment. Love this example because it goes over slope and midpoint. Anytime you forget, remember the cold hard fact sheet I gave you yesterday. It's in there, first page right in the middle. All right, first page right in the middle. x1 plus x2 divided by 2. And then I'm going to add my y's and divide it by 2. So let's figure out the points. This one's what? -2, 4. And this one down here, what? 2, -4. What is the midpoint of that line segment? Yeah, it's the origin, right? 0, 0. Can we put the two together now and write the equation of the line? Y equals, what's your slope? What's my slope? 1/2 x, and what's your y-intercept? Where's it go through? 0, so that's it, 1/2 x. Which one of those 4 transforms into 1/2 x? Don't yell anything out, I'm going to ask somebody. Which one transforms into 1/2 x? Here you go. 17. Which one transforms into it?
4.
Choice 4. Yep. Add the x, divide by 2. Nice job. Any issues? Okay, so on that one you had midpoint, slope. Well, which one haven't we? Which one do we usually also use? That's part of that trifecta. Slope, midpoint, and distance. Hey, you want to use all 3? Sure. Let's go to 32, everybody. Let's use all 3. This is now in your part 3, so now we're 4 points apiece now that we've entered part 3. Not a bad one right here for a part 3. Not bad at all. Let's get a little graph going of PQR. And while you're working, you can start the next step, which is finding points A and B, which are the midpoint of PQ and RQ. So find the midpoint of PQ, call it point A. I'll ask somebody for that one, and then go midpoint of RQ. And I'll call that point B. And then we got some work to do. Also, textbooks. If you took one out at the beginning of the year, you can start bringing those back. I have a list of people who took them out. I just don't have it up right now, but you know who you are. All right, point A and point B. What are my midpoints here? Here you go. 16 when you're ready. I mustn't say anything, Meg. Whenever you get, I'll take point A first, or whatever point you have, I'll take.
I got for point A, I got -2, 3.
Nice job. All right, somebody have point B now for us. Point B. 3. Got point B? Okay. Everyone all good? Those are my points. Those are my points. First thing they ask us to do is show AB and PR parallel. All right. I think we just talked about that, right? What am I going to have to find for both? Slopes and hope they're equal, right? If I found the midpoints correctly, those slopes should be equal. So go ahead, take another couple 30 seconds here. Rise over run or change in Y over change in X. It's up to you. Whatever floats your boat. Got any slopes there for me yet? Any slopes? 16, any slopes?
Yeah, for PR, the slopes 2/3.
You didn't find 2/3 at first. What did you find?
Wait, what? Oh,
For-
for AB?
No. You were right for PR, but you didn't find that at first. It didn't come out to be exactly 2 and 3.
Oh,
What?
no. It was, well, I just kind of went to 4/6.
Okay, and I give Maggie a hard time because, all right, reduce it if you need to. I don't know if anybody went into panic mode that it was 4/6 and not 2/3. All right, so just reduce it if you need to. They are both the same, but not good enough. Not good enough. Still got to. Some people may get 4/6 and say they're not parallel because they didn't reduce it. That's what I'm saying. Still not good enough. Just showing me is not going to do it, right? How do you know they're parallel? AB parallel to PR because slopes are equal. Just need a little concluding statement. Now here's where the fun begins. Now show me AB is not only parallel to PR, but it's also equal to half its length. Yep. Let's bust out the old distance. Or Pythag, whatever your personal feeling is. So we got to find the distance of AB and then the distance of RP and then compare them. So go right ahead. I know you're going to be devastated. Doesn't look like we're going to get to this proof. We're going to have to do it tomorrow. This exam was a beast. Two decent proofs. The one we didn't get to yet and the one we just did with the trapezoid. Thing was a beast. But manageable. It could be tamed. The beast could be tamed. Anybody getting the distance to AB? What'd you get? Surprisingly, that's correct. Anybody going to RP? Emma? Yeah. Whoa, whoa, whoa. 100% correct, but aren't we supposed to be proving one's half the other? And I don't think 13 is half of 52. Oh, so it's the square root. It's not 52, it's the square root of 52. And anybody break that down a little more? Biggest perfect square that goes into 52? 4. Oh, and look what happens now. 2 square root of. Now let's compare the two. That'll be the happiest I am for all 40 weeks is when you say, I am finished with the Regents, here it is. And I just take it with the biggest smile on my face. I'm not going to know who you are. I'll just be like, anybody know who this girl is? Is she lost? Or So yes, we did find out square root of 13 is 1/2 of 2 square root of 13. Yep, just reduce that a little bit. You don't need anything in words here because that's tough to explain in words. But you could just show me that, yep, radical 13 is 1/2 of 2 radical 13. Or take radical 52 and divide it by radical 13 and show me it's 2. Oh, we have time here. Perfect. Here we go. Save every minute here. Yep, come on, get up, get jacked. Here we go, 33. 33. I know, and it's a circle. Is this, are you kidding me? Yep, I am. Let's go. Let's do it. First of all, don't even look at, just dart right to the proof statement. Anybody know what I'm going to have to end up doing just by the proof statement? No, this is not a, you're going one step too far. Means and extremes would be the step after. This is going to be CSSTP at the end, but what do I have to do first? I got to prove a pair of triangles congruent. Yep. It's congruent. Similar. Now I'm rattled. Back there, I'm rattled. I'm surprised it wasn't, didn't you mean similar? Yes, I did. Yeah. Yeah. Yes, I did mean similar. What two triangles in particular? Well, let's see. BC and AB. Looks like it's going to be this top one with CA and EC, the bottom one here. So I'm going to have to prove those two triangles similar somehow using some circle facts. Yes. Main way of proving triangles similar, angle, angle. So the bell doesn't, can we at least see any angles up here that maybe we can mark? Hi, Emma. ACE. What type of angle is ACE? Is a right angle because it's a radius. So we're going to finish this one tomorrow, but I just want to mark it. It's a radius drawn to a point of tangency. And what else? In this triangle, where's the right angle? BA? Angle B? Because what type of angle is it? Inscribed drawn to a semicircle. Nice. And, oh, they tell us it's, hold on. They tell us it's parallel. Anybody find the other pair of angles now? Heaven? Because they are alternate interior, yes. And then tomorrow we'll actually fill in the statement to reasons with it. Reminder, your assignment tonight comes from the June one you got as you came in.